Okay, now the recording started. So guys, I have some stuff here on my table. Can you see?
Yeah.
Okay. Okay. Please help me to name these stuff. What is it? This. What it is?
It's a glass.
Okay. This one.
Glass of water.
Water, right?
Lemon.
Lemon, right?
Lovely. You will make a battery. Or no?
And this one?
Salt.
Salt, right? And some spoon, right?
Cool.
Right. So using this stuff, what do you think? What I'm going to do? What do you think? What should I do right now using these glasses, salt, lemon, and water? What should I do?
You will try to produce electricity through lemon and to adjust the salt electricity, the volts.
Your voice is breaking. Your voice is breaking. Could you just come very close to your camera or the mic?
Yeah. All right. You will try to produce electricity.
Sorry, I don't get you.
You will try to produce electricity.
Electricity. How could I do that? Tell me what I do.
If you had a copper and an iron, you could do that. Now
But
I don't see that.
Copper and nylon. I don't have it right now. I have only these apparatus. You know, the lemon, the salt, and glasses and water. Only these stuff.
Maria, you are in a chemistry background. Do you have any suggestions?
No, you have to do whatever based on these stuff only. Only using these stuff, not the copper, not nylon, any other stuff. Only these stuff.
So I'm thinking because salt it has both anions and cations, water is neutral, and lemon is an acid. So maybe creating somehow some flow of electrons, but I have no idea how we could do this. But
look, you tell me what should I do. It's up to you. I have just opened the question. I am asking you what should I do. You tell me, then I will do that. Tell me what should I do. I have the glasses, lemon and salt and water. Tell me what should I do.
To mix a solution with water, lemon, and salt in one glass of water, and the other to be just pure water.
Okay, okay, let me do that. So you want me to have that's enough?
Now the internet.
And in this as well. Okay. Okay. What should I do next? What next?
Put some salt and lemon.
Okay, some salt and lemon. Okay. So what should I do with this lemon?
Squeeze it.
Yes, come on. Tell me.
Squeeze it. Squeeze it.
Drop it.
Floating. All right. Put it in the water. Yes.
Okay. Let me do that. Oh.
Archimedes. Lovely. Okay. Put salt. Put salt.
Okay, some salt. Okay, great. Salt in this glass, okay? And try to mix it.
Yeah.
Okay. Tell me, what should I do next?
Put more salt.
More salt.
More
Okay.
salt. Doesn't need. I think we'll need.
Okay. Then next.
Put the lemon.
Okay, the lemon.
Whoa.
Oh.
Yeah,
Right. Great. Great. That's what I wanted to know. Now we did something. We did something. We don't know yet what exactly happening. I dropped the lemon in the plain water, and it goes down. And when I just add some sugar, some salt in the fresh water, the lemon floating on the water. Even I bumps it, it's going up. So what do you think? What is the reason? The lemon in the plain water is, going down, but in the lemon in the salty water, it actually going up direction and floating on the water. So what is the reason? What do you think?
the density of the water changes.
Oh, you are a brilliant student. You directly get the answer.
I'm a teacher. All right, it's a pretty cool idea in order to show you how simple this is.
You are a great student. Great job.
Great job. Thank you.
So you're right. You're actually right. The reason behind this that the density of a water and the density of a salty water, right?
Yeah.
Okay. So I'm not going to explain it in detail because you already know. But the effort is that students might not be aware about this experiment or these about the concept of density. What is exactly happening? Sometimes they feel that, oh, you're doing some magic. So they ask me, what is the reason behind this? And this is how I try to explain the concept of density. Okay. Now I'm just putting this stuff now here. I'm getting ready for the next experiment. So I don't need this stuff. Even not to salt as well. I need this bottle. I have this saucer here. And what I'm doing, I'm just adding some fresh water in this saucer. Okay?
Yeah.
And I'm adding some color. Color. Yeah. Now you can see water color it's now yellow color water. Can you see it?
Yeah.
Great. And here's the bottle. And this thermos. I have extremely hot water in this thermos. What I'm doing, I'm adding this water in this glass bottle. It's very hot. The water in this bottle is extremely hot. You can see the vapors. So it's very difficult for me to hold this bottle. So I'm using this and then taking back in the bottle. Okay. I'm just putting this bottle in this way. And now see what is happening. Can you see?
Yeah, it starts, the liquid goes up.
Yes, come on. Can you see the water level inside this bottle?
Yeah.
Right. Yeah, it's up. It's going up.
Fully.
And if I just take this bottle or took this bottle for 10 or 15 minutes, then the saucer will be empty. The whole water will be inside the bottle. So now, is this science or is this magic?
This is osmosis.
Oh, no? It's not magic. It's a science, right?
This is a science, yeah, no magic.
Yeah. So try to find out the science behind the things. Why does this happen?
Okay, because of the different pressure.
Oh, you're really excellent. You're brilliant. You know the reason every time. Great job.
I do also.
Great job. Good one.
Great.
Good. So this is how my question to you now. You are very excellent student. Okay. Instead of adding water in this bottle, what would happen if I would have added hot oil in this bottle? What do you think? What would happen if I would have added oil instead of water? Will it be the same result, or the result will be different? What do you think?
Will be higher results because the oil can get higher temperatures.
Okay, so result will be different or same? Tell me, result will be different or same?
I think it would be different.
Different. Why do you think so?
Because the oil can reach higher temperatures and can increase the pressure even more than the water.
Yeah, right. So these are the basic concept of pressure, air pressure inside the water. And you know, air is actually hot air is lighter than the water molecules, right? So highly weighted water molecules try to replace the less weighted air molecules, and that's why the water going inside the body. So this is the main reason behind this. So guys, this is what I do in my virtual trip of Science Park. So I do a couple of live experiment, where interacting with the students, rather than telling them the concept, or rather than telling them or explaining the you know, scientific rule or an equation, I want them to experiment the concept. Let them understand why does this happen. And when they start thinking about, oh, why does this happen? Is there any science? Then how does this happen? And then again, I ask them some tricky questions that right now I ask you, like replacing the water by the oil. So will it be the same result like this? So this is how we can develop that scientific attitude or the temper in the students, rather than explaining on the board the scientific rule and this would happen like this. So this is the way I teach to the students the science.
This is a very good way. I'm doing also the same thing. Can I ask you how many lessons are you doing per day on average?
In a day, I do 5 sessions.
5 sessions.
Yes.
What's the most common audience that you have? Is it like high school? Is it geographically? Is it from Europe, or is it from Asia? What's your audience?
Open to all. Open to all. Not only in India, but across the globe. In the daytime, I do for Indian school or the Asian school. And at night, most of the sessions for the American continent, South America and North American continent. So it's up to the educators, those who are, you know, interested, they do register on the website. Then I get their request and I approve, managing my style, and then I give the sessions to them.
Lovely. Can I ask my classroom if they have any questions for the teacher, because we have to move on soon?
If you are not asking me, it means you are not thinking. If you are asking, it means you are thinking.
It's very early for us here in Greece. I hope
always need to ask some questions to the students. So keep asking.
Can I ask you, can you hear me?
Yes, I'm getting your voice.
Can you tell us where you get your inspiration for your experiments? How do you think what experiments will engage students the most?
Rather than thinking about the experiment, I'm not focusing on the experiment. I'm more focusing on engagement with the students. I do so many experiments, but each and every experiment engages the students the way I'm teaching, the way I'm interacting with them. So my focus always is on engagement of the students rather not on the content of the experiment. So I do ask them so many questions so that they get inspired, they get, I just want to catch their attention rather than seeing and watching everywhere. So my focus always on student engagement by asking them questions or putting some questions, showing them some stuff, and start thinking. Let them think what they when they see some sort of stuff like this. So I inspire their thinking ability.
Okay, thank you.
Thank
Yeah,
you very
no
much
problem.
for your time. I hope all the best. And it was very nice to meeting you. Maybe we will meet again,
Yeah,
online, or in India or online. We will see. Thank you.
happy.
Thank you very much.
Thank you so much.
Thank you.
Thank you. Bye.
Thank you.
So.
So I'll
Thank
stop
you.
recording. Thank you so much.